2, 3, funky.
Hey you guys, welcome back to my channel. I hope you guys are having a good day. In today's video, I'm going to be going over calculating the forces on an inclined plane, and also I'm going to be doing a little bit of review on other just like topics surrounding the forces of an inclined plane, but the main focus is on the calculations. So let's just get started. Alrighty, so for the calculating part, especially with the sine and cosine, you want to make sure your calculator is in degree mode. And if you don't know how to do that, so with the graphing calculator, all you want to do is just go to mode and then scroll down and then degree and then enter, and then second mode, and you're out and your calculator is in degree mode. And that's very important because if it's in radian mode, your answer is not going to be right. So make sure it's in degrees when you're solving for that. Okay, so just some formulas before we get started. So we know that our force of weight, which is also your normal force, is equal to the mass times gravity. So your mass is represented in kilograms and your gravity is gravity. It's always 9.8 unless they tell you otherwise. Anyways, and then your frictional force is equal to your mu times your normal force, and your normal force again is your mass times gravity if they don't give you the normal force, and your mu and frictional force. And then your applied force is equal to your mu times your weight, which is m times g. And then you can use this formula in replacement of this one if your frictional force is equal to your applied force and your normal force is equal to your weight force. So in other words, if you have a constant velocity, you can swap these equations for one another. Well, you can replace this with this. Hopefully I'm not just talking. But now we have new equations. So your parallel component Fwx is equal to your weight, which is right here. So your Fw, so in other words, your mass times gravity times sine times whatever angle they give you. And then your Fwy, your perpendicular, is equal to weight times cosine of the theta, so whatever angle they give you. And your Fwx, aka your force, your net force, because again, Fwx is what makes your objects accelerate, and if there's no friction, then it's your net force. But if there is friction and you're trying to find your net force, all you have to do is Fwx, which is Fw times sine theta, and you subtract friction from that, and that should give you your net force in whatever direction it's moving, which should be towards friction. Actually, I don't know. You have to see the diagram to tell. I don't know what I'm saying. But that's how you find net force if there is friction. And that's it for the calculations part. Now let's get into actually applying this to like word problems and stuff. So yeah, let's go. Okay, so number 13 is asking us how we find the weight, and we know that weight is mass times gravity, so kilograms times meters per second squared. And we know that the mass is 4 kilograms and the gravity is 9.8 meters per second squared, and we multiply that together, you should end up with 39.2 newtons, and that's what you have to do for number 13. Okay, so for number 14, they're asking us what the normal force is, and we know that the normal force is now equal to the perpendicular force in the labeling video. And so if we want to find the normal force, the normal force, we'd have to use the perpendicular force to find that. And your perpendicular force is Fwy is equal to Fw times cosine times theta. Okay, so we don't know what that is, and then we know that we need the weight, and then we need the cosine times the degree. And so we know that the weight is 4.0 times 9.8, which is 39.2 newtons, which is what we solved up here. And then we know that we need to multiply by cosine of 25 degrees because that's the theta that they gave us. And then we multiply that together. And when you want to multiply the cosine and stuff, you want to make sure that your calculator is in degree mode. So what you want to do is go to mode and then make sure that this is clicked on. Okay, and now we can do 39.2 cosine of 25. And that should give you 35.5. And that's your answer. So that's your normal force. And then for number 15, we are trying to find the downhill force, and we know that the downhill force is equal to the parallel. Well, it's not equal to, it is the parallel force, and we know that because it's the parallel force that is trying to pull the object down the inclined plane. So to find parallel force, we need FWX, and that is FW times sine theta. And then we know that the weight is 39.2 times sine of 25 degrees. So 39.2 sine of 25, and we get 16.566. And when you round that up, you should get 16.6 newtons. Okay, so number 60 is asking for your frictional force. And so what I did in the situation was I found my FWY, so I found my perpendicular or normal force. And so we already know that FWY is FW cosine theta, and we know that the answer to that is 35.5. And then what I did after that was I multiplied it by the mu that they gave me. And then when I multiplied that, I ended up getting 15.1625. And then when you round that at 15.3 newtons. Okay, so to be honest, I don't really know why number 16 is the way it is. But I feel as though you would use FWY, the cos, instead of sine, because the cos is acting in the x-axis direction, and we know from the diagram that the friction force acts in also kind of like the x-axis, because it's going this way instead of like straight. I don't really understand it, but I don't know. Yeah. All I remember is that the night I was doing this, I didn't know how to do either, because I kept getting 16.6 for whatever reason, and I was trying to figure it out, and then I looked it up and I found an explanation for it, and I was like, okay, this really actually makes sense. And then I was trying to solve it again tonight, and I could not figure it out. And this is literally the best I could come up with, so I actually genuinely don't know why that is the way it is or anything, but let's move on. Okay, so for 17, they're asking what the acceleration is. And okay, so you want to take your FWX, because that is the one that is basically your net force when there is no friction. But there is friction in this case. Is there? Yes, there's friction. And you want to subtract F of F divided by mass, because to find acceleration, let me make that a lowercase. That's a lowercase a. You can't even tell. It's that your F net over M, I believe. And so I found the force, so I did FWX, the one that determines acceleration, and I subtracted that from the frictional force, which is 15.3, and then so that would be 16.6 minus 15.3 divided by the mass of 4, and when I divided that out, I got 0.32 meters per second squared for my answer. Okay, and then number 18, the last question. It's asking also for acceleration, but in this case, there is no friction, so we don't have to find a frictional force or anything like that. We just have to find FWX, because we know that it is basically the net force or the acceleration when there is no friction. But when there is friction, you have to subtract and stuff. And that's what we did for number 17. But for 18, what we're going to do is 240, because that is the times sine times 10, because that's the degree, and then divided by 240 divided by 9.8. And I hope that's not confusing to anybody. But then when we do 240 times sine times 10, we get 41.6755 that. And then 240 divided by 9.8, because we're trying to get the kilograms. So this is weight. So weight is kilograms times gravity. So we have to divide to get weight by itself. And so we get that. And then when we divide that by that, 24.4897, we get 1.7. And that's your acceleration when there's no friction. So when there's no friction, you don't have to bother about trying to find the frictional force, and when there is, you have to subtract it from your FWX. And that's it. Thank you guys for watching, and I hope you found this video helpful. I'll see you guys in the next one. Bye guys.